Have you ever worked with an AI that's almost right, but just off? It's one of the most frustrating things. Well, today, we're going to look at a totally new way to think about and debug AI, not as a simple timeline, but as a city map. So let's dive in. The way most of us learn about AI is through this really simple linear story. You've got your data, it goes into a model, you calculate a loss, and then boom, you get an output. This process view is fine. It's good for telling you when things happen, what the next step is. But here's the thing. That whole timeline view completely falls apart when the failure isn't some catastrophic crash. What are you supposed to do when the AI is just slightly, maddeningly, and subtly wrong in some really complex way? I mean, think about it. We've all seen these, right? An LLM that gives you technically correct answers, but they're just so bland. Or an image generator that knows what a cat is and what a hat is, but it just cannot put the hat on the cat correctly. Your standard process view, it doesn't give you a clue how to fix these kinds of subtle problems. For that, we really need a new way of looking at it. And this is the big idea, the key shift in thinking. We need to trade our timeline for a city map. The old process view tells you what happens next. But this new state view, our city map, it tells you where the problem actually lives. It's a spatial approach to thinking about the whole system. So our AI city, it's got 6 main districts. Each one is totally different, holds different kinds of information, and importantly, gives us a different lever to pull when we're trying to fix things. Let's do a quick tour of the neighborhoods. First up, we've got the input space. Just think of this as the city's main port. It's where everything from the outside world arrives. All your data, your prompts, instructions, context, everything the AI sees comes through here first. So, remember that kind of boring but technically correct LLM we were talking about? This is a perfect example. The problem might not be the model's core intelligence at all. It's a conditioning problem. And the fix is often right here in the input space. You just tweak the prompt, add a few examples, or clarify your instructions, and you can guide the model to the exact style you're looking for. Next, we're visiting the configuration space. If the input space is the port, this is the city's actual architecture. We're talking about the blueprints of the AI itself. Its structure, its layers, its parameters, its weights. This space defines what the model is and what it's even capable of. Yeah, this is a great one. Imagine you've got a vision model, and it just can't seem to grasp the big picture in an image. You could throw more data at it all day, and it might not help. The problem could be fundamental to its design. Maybe it just needs an attention mechanism or a wider field of view. That's a classic configuration space issue. Okay, now we're heading into the city center. This is the representation space, and it's definitely the most complex district. This is where the model's internal worldview lives. Its concepts, its understanding. This is pretty much the AI's mind. This space is so important, it actually has its own little neighborhoods. First up is the feature space. This is where the model stores its raw knowledge, all the patterns and features it's learned. This place answers the question, what does this model actually know? Then you've got the latent space. This is a bit more organized, kind of like a library. It's a compressed area where you can find these high-level controllable knobs to turn, things like style versus content. It's really the key to being able to edit an AI's output in a structured way. And finally, we have the alignment space. Now this one is absolutely crucial. This area is all about relationships. It's where the model figures out how different concepts are supposed to connect to each other. It answers, what is the model binding together? So remember that image generator problem? You ask for a red cube on top of a blue sphere, and you get them floating next to each other? The model clearly understands red cube, and it understands blue sphere. Its feature space is working just fine, but it's failing to understand the relationship on top of. That is a classic breakdown in the alignment space. All right, so we've been inside the model's head. Now let's talk about what actually comes out the other side, the output space. Think of this as the city's factory floor. It produces everything the user actually sees and interacts with. Text, images, predictions, you name it. And this shows that, sometimes the fix is right at the very end of the assembly line. If you've got an LLM that's just rambling or constantly breaking your JSON formatting rules, you don't always have to go back and retrain the whole thing. Often you can solve it right here by applying rules directly in the output space. Okay, now for a really, really important one, The objective space. You can think of this as the city's moral compass or its value system. It's where the definition of good lives. It's your loss functions, your reward models, the things that tell the AI what it should be trying to achieve.
And this is such a powerful tool, right? If your model is great on average but just falls apart on those rare critical edge cases, well, it's because you told it that average performance is what matters. The fix is to change its values, go into the objective space, tweak that loss function, and make it care more about getting those extremes right.
And for our final district on the tour, we've got the stochastic space. This place is kind of wild. It influences everything. It's where all the randomness in the system lives, from how the model weights are first initialized, all the way to how it samples its final output. It controls things like creativity, diversity, and even just simple reproducibility. You've probably seen this, right? A model that's a total genius 1 minute and then spits out complete junk the next. That wild inconsistency often isn't some deep fundamental flaw. A lot of the time, it's just a problem of randomness. By tuning the sampling temperature or the decoding strategy in the stochastic space, you can often get that quality to be much more stable. So the big thing to get is that these 6 spaces aren't just sitting there in isolation. They're constantly talking to each other in a loop that basically mirrors the training process. You transform data from the input space into the model's representation. You project that representation out to the output space. You evaluate that output using the objective space, and that evaluation then tells you how to update the model's configuration. It just goes round and round. And this brings us to what's probably the most useful part of all this. This whole CityMap thing, it gives you a brand new set of questions for debugging. Instead of just throwing your hands up and saying, the model's broken, you can start to ask where it's broken. Is it a bad prompt? Is it the wrong architecture? Is it aiming for the wrong goal? This is your new toolkit. So the next time your AI starts acting weird and gives you a strange result, I want you to remember the map. Don't just ask the old process question, what happens next? Ask the new state question, where, in which one of these 6 districts does this problem actually live?